Greetings and welcome to my new calculus channel. My name is John Gabriel. So today this is going to be a consolidation video, which means it's going to be a little long. I suggest you watch it in stages or you get yourself a cup of coffee because I'm going to try and consolidate everything I've told you about fractions and arithmetic. So the whole crux of the matter is that fractions and their operations come to you. So they come to you from geometry, okay? In other words, your dumb professor can't tell you that P over Q plus R over S is defined as PS plus QR, okay? Or that if you multiply these, that's equal to PR over QS, defined that way. That's all nonsense. It's not a choice that it's defined that way. It is that way, whether they like it or they don't, okay? So, like I showed you with my method in the previous video, Gabriel arithmetic, you can perform all the operations, every single one of them, without numbers, okay? So let's look at the first example we have over here. So we've got two ratios. One is 3 to 2, or this red line to the blue line, and we don't need to mention 3 to 2. All we need to know is this red line to the blue line and this green line to this orange line. Now remember, the first thing we needed to do was to have them have the same consequent, and we can see that these two have the same length, okay? They have the same length, so there's no need to change the consequent in this example, okay? So because quotient is the main operation, I mean, sum and difference are terribly easy. We can see that the difference here would be this little distance here, right? So this would be the difference. This distance, okay, would be the difference. And the sum would be this whole green line plus another 3 of these, right? So, and of course, both of those would be written with the same consequent. In other words, either this blue or this orange one. So that would be pretty easy to write down. So, and the last operation is quotient, because product comes from quotient. So once you know quotient, you just convert the multiplication, which is defined in terms of division, into quotient, and you get the answer. So now, what is the answer to this here? Well, let's see. So the answer is that we take this antecedent as a ratio to this antecedent here. So this is the final answer of division. In other words, if we divide this ratio by this one here, so if we divide this one by this one, okay, this one by this one, we're going to get this particular value here, okay? What you see here. This is what we're going to get. No, I didn't want to do that. Seems like I've missed my little moving button here. That's not a problem. Okay, so you might say, okay, well, how does that tell us what the length is? Well, we can find out what the length is, again, without using algebra at all. Watch. There it is, see? This magenta line here is the length, okay? And you might say, well, 3/4 isn't 1.5. Well, actually, it's this length divided by this orange line, which is a unit, okay? You mustn't forget that we're measuring everything in terms of this unit. So if you say 1.5 divided by 2, it is actually equal to 3/4, which is this line to this line here. Let me just see if I can fix that quickly. Measure, let's just do this. How's that? There you go. So now we can move this around, okay? So measure is short for measure. Now, so all we've done here is we've taken this, we've said this line here divided by this line length divided by this line length, and we've gotten 1.5, right? But it's not really 1.5 because it's measured in terms of this distance here. So it's the ratio is this line to this line, which gives us a measure of 3/4. All right. So now that we've done that, let's do another few examples. How about if we say this ratio, okay, hang on a second, this ratio to this ratio. Okay, so we're gonna try to find the quotient of this ratio on the left to this ratio on the right. How are we going to do that? Well, first thing we notice is that the consequents are not the same, right? Blue and orange are not the same, so they have to be the same, and we have to make them the same. Well, to make them the same, all we do is we extend this one here and another two there, right? Now they're the same, aren't they? The consequents are the same, which means that the quotient will simply be this line to this line here, right? So here's the quotient. Whoops, that's rather big. Let's just take away the algebraic measure for the time being. So this here is this line to this line, right? Okay. And if we look at the number of blocks, we see that it's actually 4/3. But you have to remember that the unit is almost 6 blocks, okay? So if you add in this here, you see the unit is 6 blocks, which means that this line here will be approximately 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. And if we show measures, there you go, you see? I'm sorry, but we're running out of space here in terms of real estate. So there you have it. That's one way of looking at it. And the next thing we could do is we could say that if we have 2/3, which is the ratio on the left-hand side here, divided by a half, which is the ratio on the right-hand side, the answer will be 4/3, won't it? Okay, 4/3. And why is that so? Well, because a half measures 2/3 as one of itself, okay, and a third of itself. All right, that's like a mouthful. Let's look at that. So we've got 2/3 divided. That's the example I just showed you. Okay. So what this means that 2/3 is being measured by half. Okay. So to get 2/3, we'll need 1/2 plus 1/3 of 1/2. Does that make sense? Which is a half plus 1/6, right? Which, by the way, is, if I've done that right, so this will be 3 times that. Yeah, so this will be plus 1/6, which is equal to 4/6, which is equal to 2/3. Okay? So always remember that division is a measure of one operand by the other. So that's what 2/3 divided by 1/2 means. Now, if we had said 2/3 multiplied by 2, okay, if we had said 2/3 multiplied by 2, like this, that means 2/3 measured by the reciprocal of 2, which is a half. So it means 2/3 measured by the reciprocal, which is a half. And this turns out to be the same as that, right? Which is what we just did. So we're done, right? That's equal to 4/3. So essentially, the only operation you really need to know in detail is the quotient or division operation, because the multiplication operation comes from it very easily. All right, let's do one more. Okay, let's do one more. Let's say we have 2/3 like this, 2/3 divided by, let's say, 5/6. sixes. Okay, so this is 2/3 divided by 5 sixes. What will the quotient be? Well, the quotient will be 4 to 5, right? And its measure 4.8. Why? Because of the unit being this long, or 6 blocks. So if you look at the algebraic measure, and we show so what we're looking at here now is the result, which is this magenta line, and it's measured in terms of 6. So if you say 4.8, oops, divided by 6, the answer is 0.8, right? And that's correct because 4/5 is 0.8, isn't it? Okay, so now let's do one where the unit is 1. So we'll say 3, let's say 3 times 2, like that. 3 times 2 would not be that. We'd have to invert this second operand here, okay, because this is 3 and this is 2, but remember 3 times 2 is the same as 3 being measured by half, right? So we'd have to do this. We'd have to say that's what we want, which means that we'd have to now make the consequence the same. And in my opinion, the easiest thing to do is just extend this one like that and add another 3 on there, okay? So now we've still got 3, and it's divided by half. And so what will the answer be? That's right. It will be 6, okay? And so here you'll see 12, but that's not a mistake, because if you do algebraic measure, look, whoop, algebraic measure, what you're going to have to do here is measure this result in terms of the units. So 12 divided by 2 is 6, right? And there you have the answer. So it doesn't matter how you do it, you'll always get the right answer. And I'm going to put a link to this applet so that you can play with it with any of the ratios that you like. And just bear in mind each time that the first thing you have to do is these ratios have to have the same consequent, okay? Same consequent. And if you're multiplying, you must always switch the antecedent consequent of the second ratio. And by the way, we didn't have to do this way. We could have said, all right, we could have said 2 times 3 is done like this. Okay, let's say 2, let's do 2 times 3. 2 times 3. 2 times 3 would have been that, right? But remember, now we'd have to switch this ratio. So this would be 3, and this would be 1, like that, right? 3 and 1. Okay. And now we just do a quotient, right? So what would but wait a minute, we'd have to extend this also because it's not the same as this. So if we extend this twice, 1, 2, we'd have to extend that twice as well, right? And now we can see that the resulting quotient is going to be this line here, this line, right? And we're going to have its measure as 6, right? But now what's happening here? Let's see. Since the unit is 3, this magenta line must be 18 divided by 3, which gives us 6. Does that make sense? Okay. So not to waste any more time with this, I think you've gotten the message. Now, in my publication called Learning the Correct Way, which is this guy here, The Importance of Learning the Correct Way, I give you all these details, okay, and much, much more. So, for example, I'll show you now. I answer the questions, many questions. For example, why is the product of a half times a half less than the multiplicand's? Okay, because, well, let me answer that one for you. So let's just clear this. New. So if you have a half times a half, what does that mean? What does that mean? That means that a half is being measured by the reciprocal of this guy, right? Which is 2. So it means a half divided by 2. In other words, a half measured by 2. So if we want to measure a half by 2, we divide 2 into 4 equal parts, and we only need one of them to measure half. One of them is a quarter. Therefore, half times a half is a quarter, right? I answer a lot more questions. I answer questions like, why isn't 2 times 3 calculated the same way as with fractions? Actually, the answer is, it is, but why? And why is the product of whole numbers greater than the product of proper fractions? And many, many other questions. So in order to learn these things, you'll have to buy my book. It's called The Importance of Learning the Right Way. What does division mean in mathematics, and how does it affect all other arithmetic concepts? If, however, you're a member of my new calculus members only channel and you join for €4.99 a month, you can have access to all my publications, even the ones I'm currently working on, like this one that I've just explained. Okay? And you can learn much, much more than what your professor of mathematics or teacher knows, and it can answer all the questions that you asked yourself when you were young and you didn't know the answers to. And this, by the way, affects your learning process throughout your career. I mean, you can become a STEM professional, and all you understand about this is that you were taught a rule: B times Q times R over S is equal to PR over QS. Okay, that's all you were taught. And you were also taught that that's equal to PQ divided by S over R. You had no idea why this is so. And I've given you a little insight there, but to get all the source on this, you have to buy my book. I'm sorry, it's not free. It costs €9.99, or depending on what country you're ordering it from, but it's still pretty cheap. You have to remember that this book doesn't just cover this topic. It covers a lot of other topics. It covers topics in calculus, in mathematics, in algebra. So you'll learn a heck of a lot more than you learn in a book that you pay $500 for. And you're only paying €9.99, €10, for crying out loud. And you're supporting the greatest mathematician on earth, the great John Gabriel, right? What more could you want? So become a subscriber to my YouTube channel if you're not already a subscriber. See, if my subscriber list goes up, I'll be able to at least live a decent living. I'll be able to not struggle as much as I'm struggling right now. And you can make this possible by just foregoing one of your cups of coffee or your hot beverages. That's it. That's all it costs, you know. So become a member, subscribe here. To subscribe to my channel costs nothing, but to become a members only, you pay €5 a month and you have access to a world of knowledge that your idiot math professors and teachers wouldn't know, even if they could live thousands of years. I'm John Gabriel, and this is a New Calculus channel. Till next time, goodbye.